Так, следующий доклад Дмитрий Bugaychenko из Mail.ru и расскажет нам про обработку умных данных.
Да. Всем привет. Собственно, мой доклад
Smart Data
в проекте Okta, более известном как Одноклассники. Ну, для начала хотел бы немного рассказать о нас самих. Про Одноклассники ходит достаточно много мифов. Утверждается, что у нас какая-то странная аудитория, сплошные пенсионеры, провинциальная гопота и так далее. Это все, конечно же, неправда. Что такое Okta на самом деле? На самом деле Okta — это ваша семья, это ваши друзья, это ваши близкие люди. Вот. Это море позитивного контента.
So this is lots of positive content, multimedia content, so classmates, wonderful games. If we put it all together, we can say that Okta is one of the most amazing, entertaining social media. It's a positive approach, good temper, wonderful spirits. So we're not going just to organize orange revolutions in different countries, and so this is something that other social networks do, but we are against it, and so it's just entertainment. So if people ask what kind of social networks you use, Facebook, they say, and so in contact, and then they say. Shamefully, sometimes I visit classmates to talk to my mama. I don't know, but there is nothing to be ashamed of, because those who don't visit Okru, they should be ashamed, because mama is everything. This is wonderful. Okay, Ru. And okay, now just let's finish talking about lyrics, and let's talk about the size, because most of those present in the conference room are men, and so we can talk about the economy of scale. So, what is Okta? It's hundreds of millions of users. Is billions of social connections. So 8,000 servers. So 10 million communities. And 1 terabyte of traffic a second. 6 terabytes of new data for the analysis a day. 6 terabytes every day. So, and they're available for analysis. So we are, by any standards, so we're a big project, big data. So whatever you look at it, whichever way you look at it, you will see that. So let's look at it. So 100 gigabytes. What is 100 gigabytes? 1 gigabyte is 50,000 ebooks. And that's actually all knowledge of mankind. So 10,000 musical compositions. So this is cultural legacy. So 5,000 pictures from a modern smartphone. HD movies. Yes, and one serial in good quality that you like so much. And so which is so the whole knowledge of mankind versus only one series of this movie series. So they say the same. The same storage capacity, 100 gigabytes. So it's how we use this the data. How we use 100 gigabytes. So we organize the self-organizing catalog of music tracks, and so we managed to triple the music activities. 100 gigabytes was enough to do the similar video programs. So then we increase 100% of views in the similar areas. So 400 gigabytes is a recommendation of communities. So plus 50% clicks. And then we are sorting the line. So we can increase so 20% more clicks in class sections. It's not all that we do, but so those are more salient examples. Well, where the secret is? So no secret, because data processing is just can be likened to any other software project. So we need just to first identify the goal. What is it that you want? What is it? What is desired outcome that we spoke about? That's at the beginning. We spoke about that. What is desired outcome? Then now just you need to collect all the data that you need to achieve the goal and to store it somehow. That will yield themselves to analysis, identify the specifics, logic, and then and build a model that will allow you to then put it in production, save it, and then set some more even ambitious goals next time. So first, we collect data. So there are two paradigms of how you collect data. So you can record them in certain in certain data storage systems. So you have reliability, control, a simple analysis, or you can do the aggregation of logs. So then you can collect data much faster in bigger volumes, and make it in a flexible manner, and it's very simple. But you will have problems with other things, and that's why some people are proponents like that. So some they look like that. So which side you want to select, it's your own choice. But it's not relevant anymore because a very good alternative appeared. The fan-out kill. So that's a new technology of data gathering on the basis of the line with several recipients, and each recipient sees the entire set of messages. So the most popular of this segment of the market is Apache Kafka. So we use it in Russia as well. So what does it give us? So it gives a very high speed of data collection. It supports they support very flexible tunings, where in each specific case you can find a good balance because reliability and speed of gathering. So you can say that so banking reliability, or you can just put it down to another level, shift it down. So there's millions of messages on one server, but it could be failure rate may be higher. So I can fine tune it. And what's the best? So now just we have to analyze the data on the fly. This is the flow. The stream analysis appeared. This is very important. So they will gather data to Kafka. So we save data in Kafka. Where do we save? It's not relevant anymore. So we go certainly with HDFS. Certainly I will save it there. So in which form, which shape? So there are several different approaches, diametrically opposite. So we can try to collect and save in some classical text formats, right? And so they will be very big, and so they will process slowly. But in any change of the paradigm of your data, adding fields, removing fields, so they will be the same. So it's free, you don't have to change anything, so it will be stored. And so that the scripts adapted to the old approach continue to work in the old system where another component appeared. So you can try to use the binary format. Stan sequence, Hadoop sequence file. So I can get a more compact volume, bigger processing speed. But in the sequence file, if something changes there, and then you have a massive headache for 2 weeks. So there are several approaches. So for a long period of time, we've been using Apache Avro that allows to maintain the evolution of the schemes. But then we use the Apache Parquet, and we saw what kind of speed we could get, and how compact they can be. And so now all our data. So we are transferring to this platform. What's the secret? Parquet. It's a column format that borrows many ideas from Cassandra data system, but this format is optimized for HDFS in another type of processing. How does it ensure the increase of volume processing and speed? So by many factors. So the speed can be increased that it takes only from the disks, only the columns that are needed for the query. So a user agent line that you save but you don't use it, but it takes 30% of the space. So then user engine will not be taken from the disk, and your queries will speed many times over. And then so distribution of data by columns more efficiently compressed allows, because entropy in one column is much lower than the data set in general. And owing this, so these columns instead of 20 bytes per entry, so use a few bits. Very little, so that saves a lot of space and decreases the volume. Okay, we collected, stored. Now we want to study to process. So within so now we research. So we need just to find some logic, predictable behaviors. And so, for example, to evaluate the efficiency of our managing system. So strategic decisions based on this logic. And so then it will give us new ideas, new features, and ways to improve the existing features, etc. features. So then the range of methods that you can use to do that, so it's very wide range. So you can sample our data set, and so you can do the statistics analysis, you can do the correlation analysis, visualization. Machine visualization is a very strong machine. Try to visualize your data, look at it from different angles, and you'll definitely find an insight. Or you can use this machine learning models, so easy. And this blending may help of data, so when you collect several data sets and see them together, etc. Or ideas for new features. So what about the instruments? So who is familiar with this picture? This photo, yeah. So those who deal with big data, so they know very well this photograph, and they saw that Spark is 100 times faster than Hadoop. So for the logistic regression in Hadoop, those who try to do logistic regression in big data, so they don't talk. So then executors, the servers crash, so horrible, and so the memory, the storage system breaks as well. But so there is a so old. So if you drive a nail, if you drive a nail, if you drive a screw with a hammer, it will hold better if you screw in a nail with a screwdriver, and so that is why. So there's a wide range. So we'll talk about what we use in reality. So we have Hadoop, and then but they are quite big for research. So for research, we have quick interactive script languages in Hadoop system. So there are popular languages as Pig and Hive. And so using these languages, you can easily implement tasks like extract, transform, load, calculate the statistics, aggregates, put together the sample and the data sets put together. So if you connect like Apache Test you connect to, then you can get the efficiency several times much faster, just related to cascade aggregates or multi-level blending of several data sets at different levels. You can immediately increase the efficiency. Apache Spark we use. Apache Spark. It's very important when you need to do some quick ad hoc queries to data or quickly train simple ML models. Let's see what it might say, what features it will think are important and which are not important. So very often it's useful to the sample of data, so kind of cross section, so an original aggregate, and then upload it locally, and then you can get freedom, and then use the data science instruments from Python, from R, and Octava, and this is whatever you need to use. But here, just I mentioned only one paid instrument is Tableau. You have to pay for it, so you can do visualization on Python, but in reality, to open the beauty of your data, for this you need something more serious, and Tableau is this kind of category. Visualize is much better, so it's expensive, but it's really worth it. To give you an idea that each of these instruments it has its own niche. Hadoop script languages, they operate well, but the idea to apply them is only for big data, so hundreds of gigabytes and higher. Then makes sense. And so starting from a terabyte, so the aggregate in Pig, written in Pig, so its efficiency will be much better than Java in Spark, and therefore a number of reasons. Spark is good in this niche of several hundreds of gigabytes up to 1 TB. Okay, so the whole data set to put into the storage, memory storage, and to make queries very simple. Then we understand that certainly the local instrument of like Python, R, and Tableau, so they deal with lower volumes, so just a few gigabytes, no more than that. And so each of which has a connector to the distributed system, but their efficiency is questionable. And then, so then those who see the logic, they need to build a model. So model is an instrument that allows you to forecast the response of the user to the action of the system. And in order to make sure that this forecast can be used for this decision-making process in automatic mode. The most important, so when you come to building the model, you need to identify the criteria, the quality, how you will evaluate the quality. Should be two groups. So first, the criteria dedicated to offline model check, when you check historic data, and then the criteria related to the accuracy of the forecast, and the online criteria that you'll be using for the analysis of tests. And I suggest that you base online, offline criteria at different principles. Offline is accuracy, and online is the response of the user, real response of the real users. And so not everywhere, but where you want it to apply your like retention, like time it takes the user just spends on site, etc. And so that should not, as on the face of it, should impact, but need to be studied anyway. What instruments can be used here? So the first, when you build a model, is your head. So then the second instrument, the second most important, is Google Score. So never start building your bicycle without having looked at how others build their bicycles, because in the last 10 years, while our area was developing, so all these tasks were studied, processed, and so you know exactly how the bicycle has been built, And certainly you will not find what you need right now ad hoc, but at least you will see different approaches and analyzing, cultivating, and you will be able to build a good model on the basis of the primary experience. Then let's move over to the deployment. So the model is there, offline gives good results, forecast is accurate. So then we need just to do the A/B test. A/B test to be done. We need to identify what's with KPIs. We need to identify them, and that they should be measurable. And this all the KPIs are collected, and then in real time calculated and transferred into nice looking charts. And you watch those KPIs. First, you need to find an A/B test audience. A/B test audience. Sometimes so you have a target audience, for example, if a special feature just geared for a certain community of users. Then you do the infrastructure, prepare it, and then you integrate into production. So during the stage of A/B test, you don't have to integrate it into production with all the requirements, but it should work quite fast and reliable, not to so in case of failure is to prevent that. So usually, so the model is divided into two parts at this level. Some online module that is used to process users' queries, and then offline a component in different relevancy. So then streamline, real time, and others. So you launch the A/B test, and so you know that it responds well, and then our KPIs are increasing, and that the users are happy. And then now we need just to increase functionality for the entire portal. And then so you could launch for 1 million people, so it doesn't follow that it will work for hundreds of millions of people. And so here you can see the help of good engineers. And unfortunately, very often so they have to write new standards, algorithms to make sure it goes well. And recently there is another option, is the stream analysis. Stream analysis started to use it, and many processes speed up. So we scaled, launched. It works, but then if you don't want to spend the rest of your life to support the model, so you need to automate it. Automate everything that's related to the support of its operation. So new data processing, updates, etc. All. And so then you have instruments that will allow you and the monitoring team to understand so whether everything is fine, whether the system works or stopped working. So then the technical error or the quality degradation is observed. So these instruments you need, and only after this model is fully automated and you know how well it works, so you can relax. So have some brandy and move over to the next level. What it looks like, a big picture. So there are users who operate with business logic servers, and then they are just downloaded to Apache Kafka. So what gets into Kafka, most of it is analyzed on the fly. Using Apache Samza product is used in stream fashion. So CTRs, with tops, update parameters, SVD parameters. We calculate the drift factors, etc. It's not just the statistics. So we have already real machine learning is there already. And so then there's also the stream analysis uploaded to Kafka, and then dragged into a stream in the index into the body, and so where the data so distributed between the business logic servers who made these decisions what to show to the user. All this is in a cluster, and so the data not only stream processed, but all the data that accumulated in Kafka is downloaded to HDFS, then to Parquet, and then Spark, CDE, CQL, etc. for the analysis by different drops or interactive mode with the help of Pig Spark scripts. And we can use Pig and Spark, make a sample, upload it locally, and then play with it where we need it. And certainly so this will need to be closely watched to make sure it works like a clock. So we integrated Hadoops with our portal instruments, monitoring instruments, management systems. So actually we could have taken a Cloudera distributive, but we wanted to integrate it into the general portal system. That's why we decided to take a different route, so we modified the standards and distributives of Hadoop. So I'm finished, but I don't want to finish on this as a dry note, technical note, and I wanted to philosophize a little bit. So I've been watching many projects related to data science. If this project is in a lab, data science in lab, so we collected data from contact, analyzed, processed, published an article, 2 papers, and that's it. And how we went about it. So no profit for the mankind. So very real, just generates any profit. But there is data science in industry, and this is different in industry. It's geared to one target, monetization, usually. So the main KPI of any project is money. So we need more money. And so originally, so when a data scientist from lab comes to industry, he becomes uptight. But then a few months passes, he adapts and starts to think that making money is good. And so then some presentations actually suggested that it's true. My assumption is true because the community thinks it's normal. So thank God it's not that. Data science at OKRU is different. Our KPIs, our main KPIs, they are more often than not. So they're related to the customer satisfaction, what we need, so that the users want to see what they want to see, don't want to see what they don't want to see. They want us to watch more movies, music, downloaded more pictures. Those are our main KPIs that we fight for. And so certainly we're not doing it out of the goodness of our hearts. So we do have some projects that has to do with money, because without money you cannot even just buy servers to store 6 terabytes a day. But we have an understanding that investing in customer satisfaction and loyalty, so those long term will get much more than just so killing the hen that lays golden eggs. This is very important, and I hope that we'll be able to do it at classmates and to keep the good work and continue doing the same thing. Thank you very much for your attention. Questions? Thank you for the wonderful presentation. My question. So then my question is a public question. So all these issues that you discussed, they complicate the system. Costs are incurred, and so hardware, it's very expensive. So how would you assess to what extent? So then, is it worthwhile? Is introducing such complicated things? Machines make decisions, etc. Very expensive. It's a cost center. How much does 10 million classes and classmates? How much? 10 million. How much do they cost? It's an ecosystem. Production, what you've shown. So this is to what extent? So the portal has become more difficult. It has made the portal more complicated. The key issue is the watershed. It's in any complicated system a good module. Outside, it's simpler than inside. Inside, it's lots of systems, very complicated. But outside, the portal operates only with streaming index. That's it. The database. That's it. Very, very simple. So how these things get into streaming index, not important, not relevant. The CTRs. Give me the CTRs of this object. But to get this CTR, and so Hadoop cluster, so job Kafka, whatever, just collects information, shows. So you don't have to see that. Aggregates, downloads, uploads, tracks, whatever. For the portal, it's not important. For the portal, it says a storage where it can be found in red. That's it. So we do have requirements for scalability, reliability, failure proof, etc. And then redundancy, distribution, data center. So it's all done there. So it can keep a great deal of load, and it will work 24/7. In Hadoop component, high availability mode should not be any failures, but failures occur. But for Hadoop, it's just for half an hour, just to be idle time is okay. Hadoop for half an hour is okay. But since the portal operates with streaming index, it doesn't feel that. So the CTRs start to get obsolete. CTRs are not actual anymore, but globally nothing happens with the portal. So even those who monitor it don't respond. So it's just this 1.5% reduction of likes. That's it. So it's nothing. And so for this, just we raise Hadoop, so they recalculate CTRs, continues to work. That's it. So this watershed, we divide thresholds, and so then simple device. There is no complexity. This picture, how many engineers are doing all that? Let's we have an admin team, deployment, etc. So then development, development and tuning it. But one only me, myself. I'm doing it all by myself. But to make sure that there's a admin on duty, and so has gotten, and then just that maintains the entire portal. But developments and fine tuning, it's one person, and so for what's good about the system is you've seen that all the modules already. Apache Hadoop is finished. Apache Kafka is finished. So they're all ready made, and so that's off the box solutions, out of the box solutions, and shelf solutions, and so it's not a development from scratch because we do have a good basis. And but how many in open source community so to develop Sound, Hadoop, Spark, Bigup? So how many they develop? So there are many. So there are thousands of people, many developers work on that issue.